So here's a fourth set of questions related to energetics. They're all multiple choice past paper questions from old AQA A-level chemistry papers. They do take quite a little bit more work sometimes. There's a lot of calculation involved. So do pause each question and see how you do. First question. And we want to know what the enthalpy of formation for TiCl4 is. Well, we need to build a cycle. So I'm going to start by putting in the equation that's at the top of this with negative 232. And we're going to see how we can build that cycle around it. We have been given the enthalpy of formation of TiO2, negative 912. We've not been given the enthalpy of formation of carbon or chlorine, but by definition, they are zero. So my total enthalpy change for this particular component or part of the cycle is negative 912. Now, I've also been given the enthalpy of formation of carbon dioxide or indeed combustion of carbon, and that's negative 394. And I want to know what X is, the enthalpy of formation of TiCl4. So I've got all of my data in. Now I need to identify my two routes. I've done blue and I've done green. And I'm going to take the numbers from each of those and put them in. We can use the colour coding to see where they've come from. And I can rearrange that to make X the subject. Now that means that X is equal to negative 750, and we have our answer C. Next question. So in this, we've been provided with enthalpies of formation, and we want to know the correct value for the enthalpy of combustion of ethanomide. So I'm going to start off by writing out the equation for the enthalpy of combustion of ethanomide, and I've got my X in there ready to do the calculation. In terms of formation data, to make CH3CONH2, I need two C's, 2.5 H2s, half an N2 and half an O2, and my overall enthalpy of formation there is negative 320. I've also got my enthalpy of formation of carbon dioxide and water. I'm doubling my enthalpy of formation of carbon. I'm multiplying my enthalpy of formation of water by 2.5 because I'm following the balancing of the equation. I wasn't given nitrogen, but by definition, the enthalpy of formation of N2 is 0 kilojoules per mole. So I've now got my values for each of the three sections of the cycle. I identify my two routes, my blue and my green. I rearrange to make X the subject, and I find that X is negative 1183, it's B. Next question. And this is a straightforward definition question. How well have you learned these definitions? So, enthalpy change when 1 mole of a compound. Now we're making 1 mole of a compound here. So at the moment it could still be absolutely any of them. Is formed from its elements. Well, we can now dismiss B and C because it's been formed from gaseous ions. So we're now down to 50-50. It's A or D. It's formed from its elements in their standard states under standard conditions. Now in A, there are two errors. Lithium does not exist as a gas at standard conditions, and fluorine is diatomic. Both of those are correct in D. Lithium solid plus half F2 gaseous. So the correct answer is D. Next question. So we want to know the enthalpy of formation of carbon monoxide. And we've been given lots of data here that we can start to build a cycle from. So I've put my C2H4 plus 2O2 goes to 2CO plus 2H2O at the top. I've got my negative 758. And I was given the enthalpy of formation of C2H4 as plus 52. I wasn't given the enthalpy of formation of oxygen, but that's 0 by definition. On the other side of this, I'm going to look at my enthalpy of formation of water. In this case, it's gaseous water actually, so technically not enthalpy of formation. And that means that I've got negative 484 from there, and I've got 2x for my enthalpy of formation of CO. I've got all of my data in. I identify my two routes. From those two routes, I submit the figures. I rearrange to make 2x the subject. I calculate 2x as being negative 222, which you can see has been left there as a distractor answer in part C. We want the formation of 1 mole of CO, so we halve that and we get negative 111. Correct answer is A. Next question. So we want the enthalpy change basically for breaking apart a methane into a carbon and 4 hydrogens. Let's start the cycle by adding that at the top, putting my X value. Now from there, I know that to make CH4 from C and 2H2 is negative 75. I also know that breaking H2 into 2H is 436, but I'm doing that twice, so that comes to 872. And my enthalpy for carbon, well, it's unchanged. It stayed as carbon, so that's 0. I've now got all 3 sets of data, so I can find my 2 routes. I've got my blue and I've got my green. I substitute the figures in accordingly based on those 2 routes. I rearrange to make X the subject, and X is plus 947. Correct answer D.